On August 30, 1994, in Gallarate, in the early morning, engineer Filippo Zapata took one last look around him and then left this world. He had breathed the air of our beautiful peninsula for exactly 100 years, which had passed less than a month earlier. He was a tenacious and intelligent native of the March region, who had made his mark in Italian and French industry. He was an engineer at Blériot, where he designed the splendid 110, a record-breaking airplane that earned him the Legion of Honor. He also worked at the Montfaucon shipyard and amassed another crop of records with the Cant Z506, which earned him the gold medal of the Aeronautical Order. He then worked at Bradar, where he designed the magnificent 308. Finally, he worked at Augusta, leaving his indelible mark on some of Italy's finest multi-engine aircraft, such as the famous Cant 1007, the Regia Aeronautica's finest bomber. The Cant 1007 had an extremely efficient wing, with refined aerodynamic lines and exceptional fuselage connections. Engineer Zapata had worked on other projects before the Cant 1007, all of which were made of wood and always of exceptional quality. At Cantieri Riuniti dell'Adriatico, a small aircraft manufacturer but fueled by top-level technicians, workers, and designers, he had designed excellent aircraft such as the Cant Z501 and the Cant Z506. The Cant Z1007 was an aircraft that exceeded 13,000 kilograms at takeoff, with a bomb load exceeding 2,000 kilograms. But Zapata had also applied himself to metal construction, again at Cantieri Riuniti, developing two exceptional aircraft, the Cant Z5111 and the Cant Z1018. The aircraft took shape in the experimental section of Cantieri Riuniti, while in the Aeronautica Seconda shed. The wooden construction techniques that would be used on this multi-engine aircraft were refined. Zapata had already worked at Cantieri Riuniti in the 1920s as engineer Conflenti's assistant. Immediately after the company's aeronautical design division was founded in 1923. He left a few years later, returning in 1933, enriched by further extensive experience, especially abroad, and, most importantly, now as head of design. The Cant 1007 was a low-wingspan, three-engined monoplane with a wooden structure. The fuselage had an elliptical cross-section, made of wood with tulipwood slats. The two pilots were seated in tandem, to reduce the fuselage's cross-section and improve its aerodynamics. The wing had wooden spars and plywood skinning up to the rear spar. The entire wooden structure was covered with varnished canvas, including the ailerons and flaps, also made of wood with varnished canvas covering. These flaps had been specifically designed by engineer Zapata and were very well developed, allowing for very easy landings, even at steep angles of descent. The aircraft took off from a runway of just 280 meters, despite its 13 tons of total weight, and landed in 440 meters. Furthermore, in the event of an engine failure, it was capable of climbing to 5,500 meters in 24 minutes and 54 seconds, maintaining good turning ability, as demonstrated by Colonel Torre in Guidonia. The tailplanes and fins, both single and double, were also made of wood, offering excellent performance. The choice of double fin allowed the dorsal gunner a wider field of fire to defend the aircraft, as well as allowing for better directionality thanks to the action in the slipstream of the wing engine's propellers, counteracting the stern thrust. The landing gear was retractable and completely disappeared into the engine nacelles, while the tailwheel was non-retractable. The engines had 3-bladed metal propellers with variable pitch. Electrically controlled. The defensive armament consisted of a 12.7 mm Scotty or Bredar machine gun in the dorsal position, another 12.7 mm Scotty machine gun in the ventral position, and two 7.7 mm SAF-3 machine guns for lateral defense. Since returning to the company in 1933, engineer Zapata had dedicated himself to wind tunnel studies of various aircraft models, including the Cant Z-1007, on which a wealth of exceptional research was concentrated. He succeeded in bringing it to a level of fantastic aerodynamic refinement, studying the optimal wingspan. The desired flight characteristics, the total weight, the engine power curve, the required ceiling, and the maximum range with the optimal fuel load. Zapata meticulously designed and redesigned the wing planform, the wing cone, the spar structure, and the plywood sheathing, demonstrating exceptional skill in structural and aerodynamic analysis. This was done to ensure the most straight possible tracing lines for easier spar assembly and to minimize the curvature of the plywood sheathing sheets. He studied the stress along the lines using compression and tension differentials. Particularly sophisticated was his use of the resistant structures of the two spars, and how they effectively transport all stresses in all flight conditions. He also studied how the wood fiber weave was managed to prevent sudden failures, while ensuring that stress peaks were redistributed as much as possible. Even the elastic axis, that is, the locus of the centers of rotation of the wing sections, demonstrates how accurate the engineer Zapata was in calculating the pure torsional moments and the bending without twisting of the wing. It is also exceptional to observe the accuracy with which the moments of inertia of the spars vary according to the same law, and the elastic axis can be seen to almost coincide with the center of gravity of the moments of inertia of the spars. And this can be seen even more by examining the data of the static tests where the wing was subjected to a well-calibrated load distribution so as to make each resulting section coincide with the elastic curvilinear axis. Even the average elastic axis of the wing resistance box responds excellently to the differentials in torsional moments, and not by chance. And the sections can be seen to rotate around the axis of the box with minimal deformations, even at strong twisting angles created by force to test its redistribution capabilities. If we then analyze the bending moment diagrams on the spars, under all expected loading conditions, we see the excellent result that the sum of the shear forces is almost equal to the resultant of the loads applied to the wing from the tip to the section under consideration, thus avoiding possible elastic deformations between the ribs and the planking. This is enough to trigger Stendhal syndrome. This result speaks volumes about the design expertise that engineer Zapata was able to impart to his projects. The almost identical elastic deformation of the two spars is also remarkable, testifying to the excellent distribution of the concomitant bending. I must point out that this exceptionally balanced and gradual distribution of the torsional moment between the two wing spars could only have occurred with appropriately designed and constructed wooden structures. While if they had been built in light alloy, including the wing box, this virtuous distribution would have been impossible, inhibiting optimal structural characteristics and requiring reinforcements at various points to manage the resulting peaks in stress and deformation of the surfaces wetted by the aerodynamic flow, especially during maneuvers and with a near maximum payload. There would be so much more to say, but clearly we'll be talking here for days. So I'd prefer to delve deeper into the subject in a detailed book to truly delve into the soul of this design and construction expertise. Unfortunately, the Cant 1007 suffered from engine-related problems, both with the original 840 horsepower Isotta Fraschini Asso, which were never fully satisfactory, and with the later 1000 horsepower Piaggio PXI radials, which suffered from serious reliability issues. Engineer Zapata completely redesigned the aircraft to take advantage of this increased power, expanding the cross-sections, the engine nacelles, and the front fuselage with additional wind tunnel testing. It's worth noting, when comparing it with similar Italian and foreign aircraft, how excellent aeronautical and aerodynamic design immediately stands out, given that with a total of 3,000 horsepower, it was possible to reach a speed of over 460 km per hour, and the aircraft needed only one engine to stay airborne, even without compensation. General Amedeo Fiori of the General Directorate of Construction of the Ministry of Regional and Aeronautics examined the project in detail and found it extremely brilliant, clearly promoting rapid approval for series production. The aircraft frequently suffered from problems with detachment and structural deformation, especially in Mediterranean operations. There has been talk, but it is still little, very little, compared to what this aircraft can say. I will make sure that from time to time, I will talk more about how Filippo Zapata was an exceptional designer both in the field of wooden aircraft like this one, and in metal ones as we will see. I wish you a pleasant evening. See you soon.